All right, let's do some proofs. So, Theorem 4.3 in your book, in section 4.1 still, says that if we take v to be a vector, you know what? We need u and v. So v and u to be vectors in Rn, and c a scalar, then this means the following are true. Okay, so the additive identity is unique. So your book gives us a definition, very informal definition of the additive identity. Right? So let's see, in this equation here, which one would be the additive identity? Well, you want something that you would add to vector v, and then you would get vector v again. So this is the definition. That means u is should be the additive identity. Now here we're not disputing the existence of the additive identity. We're just we're going to try to show that it's unique. That there's not two of them. There's only one of them. The additive inverse of v is unique. So that means if you add u plus v. So assuming that u is the additive inverse of v, then there's not two of them. There's only one additive inverse to each element. And here, if you multiply a vector by the scalar 0, then you get the vector 0. If you multiply a scalar by the vector 0, 0, you should get 0, 0. And if you multiply a scalar by a vector and you get the 0 vector, then either c is 0 or v is 0. And then the additive inverse of the additive inverse is the vector you started with. Okay, so let's try to do a quick proof of property 1. So what I'm going to do here is I'm going to use the definition of additive identity that the book so informally gave us. So we're going to start with, suppose that, so let's put some words in here. We're going to suppose that u plus v, and of course we're assuming u and v are vectors in Rn. U plus v is equal to this other vector v. Okay, so we are to assume the existence of inverses for each one of these vectors. So what I'm going to do is I'm going to add negative v to both sides. Negative v being the additive inverse of v. So then let's see what happens. We're going to do u plus v plus negative v is equal to v plus negative v. Okay, so because I know that negative v is the additive inverse of v, that must be equal to the 0 vector. So that means u plus the 0 vector should equal the 0 vector. So that means u is equal to the 0 vector. So I just showed that this other guy that did the job, so u here in this equation, u did the job of the identity vector. And so it ended up equaling that. Now this can be restated in terms of proof by contradiction. So I really like that better. So this is the way your book is doing it. I don't like it very much, but you could restate it in terms of proof by contradiction. So what you can do is you can assume that this vector v has two additive inverses, and then you can show. So as an exercise, you can try this. So try to assume
V has two additive inverses, so you can call them U and W, right? So then you have to describe what they do, and then show that they must equal. Okay, so you can try that and see if you can figure out how to do it.